Morning 801, welcome to day 3 of week 12. Today is June 10th. We're going to continue with our final figure for volume, which is going to be our sphere. We did this when we were in school in the fall, so it should be pretty familiar to some of you, but I know using a different calculator may be a little tricky, so I'm going to make sure that we go over the steps so that you can solve it with the calculator that you are using. All right, so we'll go to our classwork tab. Any work that was submitted that has not been graded within the last 2 days, I plan to grade this morning, so you should see those grades updated. So that includes work from Monday and Tuesday, because today we had professional development, so I didn't get a chance to review any submissions from those 2 days. If they weren't in by like 5-ish, maybe 6 on Monday, I didn't get to look at those yet. So I will this morning and update them on Pupil Path. So if you click on your lesson for day 3, you'll see there are 2 links for support if needed. One was 6 minutes, one was 3 minutes, so just additional help if needed. You'll click on your lesson for today and you'll see the following. So the warm-up is just what real-world objects are in the shape of sphere. So you would think about, where you see spheres in your normal day. I'm just going to bring this up a little bit. Okay. So this was just a cute picture, I thought. So you have the beach ball, you have a basketball, a globe, an orange, all different things that could be in the shape of a sphere, okay? So when we calculate the volume of a sphere, when we were in school, we were using this formula, the top one, with the 4/3 times pi times radius to the 3rd power. For most of us, we don't have a fraction calculator at home, so I think that this formula will be easier for you to find that volume. Both of these are the same, so if you see a problem using the fraction one, it doesn't mean that it's incorrect. It's just they probably have a calculator that can use that function. But for our purposes, if you do not have a fraction calculator, I recommend using this formula because it's a little easier to calculate without that function on your calculator, okay? All right, so the first question is provided here, and I'm going to walk you guys through it just so you can see how to do this at home. So we are given a sphere, and in our sphere we're given a diameter because the length is going from one side of the circle through the center to the other side of the sphere, right? And that circle that's in the middle. So I'm going to list the information like always as our step 1. So my diameter is 66. And we are looking for the volume. The volume formula that I'm going to model is going to be the 4 times pi times radius to the 3rd power. Make sure you remember that sphere uses the 3rd power. This is a little different because we're so used to putting squared. So remember that sphere is to the 3rd power, okay? And then over 3. So now looking at this formula, I realize that I need a radius, and we were given a diameter. So if my diameter is 66, then if I split it in half, I'll get my radius equals 33. And that's all we're given about a sphere, just the diameter or radius, okay? Because that's all we need in our formula to plug in. So I'm going to rewrite that formula at the top of my board. So we have V equals 4 times pi times radius cubed over 3. And now we'll plug in the information that we know. So that's just going to be the radius. So V equals 4 times pi times the radius was 33 cubed to the 3rd power. So same as before, we always do our exponents first, order of operations. 33 to the 3rd power is the same as saying 33 times 33 times 33. So if you don't have a calculator that can be raised to the 3rd power, then you would just do that in your calculator instead. And that product will give us, let's see what we have left. So V equals 4 times pi times, that product would be 35,937 over 3. Okay, now similar to before, we don't like working with this fraction. So to get rid of the fraction, a fraction indicates division. The inverse would be to multiply. So we're going to multiply by the denominator, which is 3, because 3 over 3 will cancel to 1. So I can cancel that out. I'll be left with just my numerator. So I'm going to rewrite that here. 4 times... Oh my goodness, I'm messing up. I'm thinking we're solving for something else. Let me take that back. Okay. Hold on. I'm thinking we're solving for the radius. I'm a day ahead. Okay, sorry. So we're looking for the volume. So we don't need to do that yet. We'll do that tomorrow. What we're going to do now is multiply 4 times the other constant, okay? And we're going to leave pi alone. So you're going to now do 4 times 35,937, okay? And that product will give us 143,748 times pi. That's still there. We didn't multiply it. We just left it to the side, over 3. Okay, so now what you do is you take your fraction. Again, we're just pretending like pi is not there, and we stick it on after until the end. So that's like what we did here. We pretended pi wasn't there, and we just multiplied these two numbers, stuck it back on. We're now going to divide these two numbers and stick pi back on after we find that quotient. So when we divide these two numbers, we're going to get a quotient of 15,972 times pi. And the reason why I have you guys leave that pi there is because if the question ever asks you to answer in terms of pi, this would be your final answer. Okay, so sometimes they do, so just be mindful of that. That's why you do all of the operations and just keep pi, you know, dropping down as you do those other operations until the only thing left you can do is multiply by pi. Then once that's your final step, we'll do that multiplication. We're going to get V equals 50,177.51786 and so on. Okay, but we're going to round to the nearest tenth. So if I'm looking at my decimal, I have a 5 here, but a 1 here, so the 5 would stay. So I'm just going to put my final answer to the left because I ran out of room. So V equals 50,177.5. And remember, we're back to volume, so our units are going to be cubic, so feet cubed. And that would be our final answer for the volume of the sphere. Okay? So let me just go back to what we did, especially since I had that little mistake at the beginning. So we have our sphere. We were given a diameter because it's stretching from one side through the center to the other side. Since we're given a diameter, we know we have to split it in half to find the radius, since our formula requires a radius and not a diameter. Then I rewrote my formula and I plugged in the radius that we found, which was 33. Exponents first, it's to the third power, so that's the same as saying 33 times 33 times 33. We get our product. Then you're going to multiply the two numbers that are in your numerator, leave pi off, put it back after you get that product. Then you're going to divide the number by 3, your denominator, and then put pi with that quotient. This would be your answer in terms of pi. If you are told to round to the nearest tenth, you would then multiply your coefficient by pi, get your answer, and then round to the given place value. Remember, units cubed. Okay? Everything I just did is in the lesson, so you can look at that as well. If we keep going, there's the steps, exactly what I just took you through. Okay? Pretty clear, I feel, too. Exponents, multiplying the numerical factors, simplify the fraction. Okay, so use those as a guide. There's a we do. In the we do, you are given a radius instead, so you don't need to go that extra step and split the diameter because the radius is already provided. It's going from the center to one side. It's not stretching across the entire sphere. So again, step 1, you would identify the information given, which is shown right there. 42 meters is our radius, and we are looking for the volume. And then step 2, you plug into the formula and solve. So here we plugged in 42. Exponents first. So 42 to the third power would be the same as 42 times 42 times 42. And that product is shown right here in my numerator. You then multiply the numerical factors in your numerator, and you would get this product here, 296,352 times pi. Then you're going to pretend pi is not there and simplify your fraction if possible, which we can. The quotient of those two numbers is 98,784 times pi. This is your answer in terms of pi, but we are looking for it to be rounded to the nearest tenth. So we get this as our product. Round to the nearest tenth, the 0 would bounce up 1 because that 8. So our final answer would be 310,000 339.1 meters cubed. Okay, there's another one for you to try on your own. Answers on the following slide. A real world application where they give you the globe. The globe of a moon has a radius of 10 inches. Find the volume of the globe and round your answer to the nearest whole number. So that's the only difference from what we've been practicing is where you're rounding to, but everything else remains the same. Identify what you're given, plug it in, use your steps, and solve. Notice our final answer is rounded to the nearest whole number. And then you'll have your exit ticket for your final thing to do for the day. So I'll show you where that is. So that's right here. You would click on your form. I think it's only 6 questions. Let's see. Yeah, so your formula is at the top, and then the directions are here. Make sure you're using a scientific calculator. If it's your phone, turn horizontally, locate pi next to rand. Otherwise, use the calculator link provided at the top, okay? Just be mindful if you are given a radius or a diameter. Remember, if you're given a diameter, you have to split that into 2 before you start solving. Okay, yeah, so it's only 6 questions. Take your time, check your work, and click submit when you're done. Take care, guys.